Hi, welcome to Exploring the Illusion of Free Will. My name is George Ortega, and this is episode number 164, Free Will, Refutation, Cost, Role in Climate Change Denial, Part 4. Okay, this is like a series where I'm reviewing my book that I published in April of this year. It's called Free Will, Its Refutation, Societal Cost, and Role in Climate Change Denial. And all right, so we'll get right into it. So we're on page 7. We're going to go through the entire book. All right. I guess the way what I usually do is like go through an intro of like, giving a definition of free will and why this show is important and all that. So basically, all right, free will is the belief that we are free to decide what we want to do, think, say, feel, whatever, without anything that's not in our control, either compelling us to do what we do or influencing our decision. Because even if something just influences our decisions, then we wouldn't have a free will. Because our will would be a combination of, us and whatever's influeing us, whatever. So, all right, so the basic reason why we don't have free will is because of this principle of causality. And I noticed that that on page 7 of the book, I actually start going into that. So rather than explaining it, let me just go right into the book and so go through it. All right, so let's see. All right, so basically the premise behind this section is that causality, this law of cause and effect, is irrefutable. It's as irrefutable as the fact that reality exists and the fact that reality is in motion. So let me go through this. So, all right, I say causality is in fact so fundamental a universal process that it is a priori. Okay, a priori means self-evident, and like there's a couple of definitions of a priori. One means like self-evident, for example, A equals A. Okay, this table is a table. You can't dispute that, right? But there's another kind of like form of a priori that Kant referred to, and which is a bit different. The two examples he uses as a priori, phenomenon or facts are actually causality and time. So anyway, so like, causality may in fact be a posteriori, which means like, deduced on based on certain facts. But it's kind of like a debatable point. But anyway, the idea is like it is so fundamental, it's so self-evident that it's irrefutable. Okay, so like why is that? Okay, the first a priori fact of the universe is that it exists. You can't deny that. Now, I don't care if like some people say, all right, reality is a dream maybe or whatever, or like what we're perceiving isn't reality. Doesn't matter how we perceive or define this universe reality. We know that it exists, okay? That's like beyond doubt. All right, and the second a priori irrefutable fact of existence, as I said before, is that things are in motion. Like if things weren't in motion, this show wouldn't be happening. You wouldn't be watching this. Nothing would happen. The universe, no Big Bang would have ever happened. The universe would have been, eternally motionless. Nothing would have happened. So we've got two a priori facts about the universe, indisputable. All right, so like now here's the thing. So why is causality as irrefutable and as a priori? Think of what motion is. Okay, let's go right into the physics. Basically, motion, because I'm going to go according to what I wrote in the book. All right, motion is a manifestation of change. In other words, the universe changes. That's another way of saying it's in motion. So what is change? Okay, from a physics standpoint, you have, for example, the universe at the moment of the Big Bang, okay? Then the second moment, it is different from the first. And the only thing that, all right, so it's different. So the other way to describe change or motion is like, at any given moment, you have, let's say, any given particle in our universe. It's at one position, one moment, and the next moment, it's at a different position. The preceding moment, it was at a different position. So like change is manifested by particles, mass energy, being at one position at one moment in time and at a different position at another moment in time. That again is irrefutable, okay? Like, and even if like you were to let's say speculate or claim that you could like detect a particle, let's say, on the Earth that you claim is motionless because you don't see it moving, whatever, even that wouldn't be accurate, because like you have to understand the Earth is rotating around the sun, and the sun is rotating, you know, with our galaxy, you know, around itself, whatever, and this galaxy is moving through the universe. So there's various forms of motion. So, you know, even what appears to be completely still relative to our subjective Earth experience is actually, in fact, in motion. All right, so so basically, so that's the idea. That's and again, like, you know, like, so the universe evolves from moment to moment. The Big Bang caused the second moment of the universe, which caused the third moment. And we know this because, like, the Big Bang was the universe. That was the only thing that could have caused the second moment. And so the universe evolves moment by moment, step or stage by stage, whatever. All right, so going back to the particle, why do I say that its motion is caused? Well, in physics, we know that mass energy is propelled by what we refer to as momentum. Momentum is the direction and velocity of a particle, and we know it's always conserved. In other words, like when a particle interacts with another particle, one particle will gain momentum, another will lose it. You know, same with mass energy. But the idea is that, like, so it's momentum that causes the particle to move from one position to the next, and that's why causality, this law of cause and effect, is so fundamental. It's irrefutable. You just can't refute it. Okay. Causality is not just fundamental to nature. It's also fundamental to science. And what I'm trying to say here is, like, some experiments attempt to disprove causality by using empirical evidence according to the scientific method. Now, I'll tell you why those attempts are just flawed from the beginning. You know, they're just complete non-starters. And I have this actual, all right. Basically, the reason is our empirical science is based on this principle, or this protocol that we refer to as scientific method. Okay, we have a system of determining scientific truth, okay, and it's called the scientific method. And basically, the scientific method relies on this principle called same cause, same effect. That's what it's referred to. In other words, like, in order to establish scientific knowledge, what they do is let's say they conduct an experiment, right? And so if they conduct it a second time, and a third time, and a fourth time, and a fifth time, same conditions, they get the same results, same causes, same effects, then they know they're onto something. They know they're onto a fundamental truth about whatever phenomenon they're investigating. All right. So basically what I'm trying to say is, like, without causality, without cause and effect, there would be no science. There would be no scientific method. Oh, sorry, according to that, so this is a great sentence. I've got this in italics, because, you know, and I can't take credit for this because, like, you know, I was completely compelled to do this. I don't have free will, but it's an excellent sentence the universe compelled me to write. It says, so therefore, categorically and in principle, an a priori universal causality founded on the a priori process of change cannot be successfully challenged through any manner of empirical evidence considered within a scientific method that requires causality in order to arrive at a hypothesis. All right, so essentially, you cannot use science or empirical evidence to refute causality because, like, the science, the evidence that you would be using would be causal. The method you'd be using to try to refute causality would require causality. And that, incidentally, is another reason why you don't have free will, why free will is an illusion. In other words, like, free will, the concept, the notion of free will says that we, human beings, cause our behavior without anything causing us to cause it, whatever. But, you know, as we just, like, what happens with causality is, like, another way to express causality is that everything has a cause. Okay, causality means that, like, you know, that everything that happens has a cause. All right. So what happens is, like, so if what we decide has a cause, and then there's a cause to that cause, and there's a cause to that cause, and these causes are regressing back in time, because a cause can never come after an effect. It has to always come before an effect, right? So you have this chain of cause and effect regressing back to our every decision, and that is what refutes free will. But like what I'm saying is, like, you know, in other words, the notion of free will requires the causality. In other words, to make the notion of free will intelligible, coherent, it requires the causality that refutes it. You know, to say that you know, we caused, our will caused freely, whatever, our decisions, is to say that you acknowledge the existence of causality. But once you do that and you recognize that this causal chain regresses back to before we were born, you understand why absolutely none of our actions could in any way be, you know, up to us. All right. So all right, another refutation that I go through in the book, and I just give this like half a paragraph because it's so evident. I'm going to read it because, like, you know, whatever. All right, universal causality is also evidenced by the law of conservation of momentum that governs both macro and quantum levels of nature. Because canonical momentum is never created or lost in particle collisions, the gain or loss in the canonical momentum of one particle is caused by its interaction with the other. So that the idea is, like, so momentum is what causes everything to happen. And actually what this statement is saying is, like, again, I said it before, like, if you have an interaction between two particles, one of them is going to, like, lose mass energy, one of them is going to gain mass energy. One of them is going to lose momentum, one of them is going to gain momentum, because these momentum and mass energy are governed by these physical laws called conservation laws. Conservation of mass energy, conservation of momentum, canonical momentum. So that means you can't either create or destroy either momentum or mass energy. So again, because it's a causal process, that's another way of refuting free will, of establishing causality as fundamental to nature and thereby refuting free will. All right. So some people, you know, this illusion that incidentally, of course, the universe compels us to have, because it's not like we're choosing it of our own free will, but this illusion is very powerful. It confuses very ostensibly intelligent scientists who otherwise do, I presume, good work. But this, you know, with this topic, they feel the need to believe that they are the authors of their, you know, actions so strongly that their desires kind of like hijack their reasoning. They're not able to, like, understand these simple concepts. So they are simple. I mean, what I'm saying is, like, you know, a fourth grader could understand it, actually. All right. So anyway, so, like, there's some free will defenses that try to defend free will by saying that, well, you know, like, they say that, well, we have this universe, this physical universe, but our decisions are not physical. They refer to them as numinous or spiritual or non-material, you know, suggesting that somehow, because they're not physical, they are exempt from or not governed by this law of cause and effect, this law of causality. All right, the first thing I could argue is that these decisions are, in fact, physical. Actually, I'll argue that along with this, but all right, here's the thing. All right, the problem with this argument is that, let's say you attempt to describe a decision as being non-physical, numinous, you know, spiritual. All right, the problem with that defense for free will is that decision takes place at a moment in time. Okay? Now, what happens, time is the measure of mass energy moving through space, the rate of motion, how quickly it moves, you know, how long it takes to get from one point to the other. So clearly, time requires both mass energy and space to exist. Without mass energy, there would be no time. So in that sense, time, mass energy, and space are physical, because that's what the universe is comprised of. In other words, to say that anything is occurring in time and try to say that it is nonetheless somewhat physical, it's illogical. It's an illogical conclusion because the moment something takes place in time, it is part of the fabric of the physical universe. Otherwise we'd have to say that, well, this decision we're making, this spiritual decision is being made outside of the universe, and that's just like impossible. That's, that doesn't happen that way. All right. Then like some physicists, because this illusion of free will is very, very pernicious. It's very, very strong. It's probably the most powerful illusion we have. I've heard other scientists, philosophers, psychologists refer to it, and I believe that. All right, but like they say, well, they try to refute causality. And, if you've understood what I just went through over the last, 20 minutes or so, you'll understand how that's not possible. But they say, well, in quantum events, at the quantum level, actually some events are indeterministic or uncaused. In other words, like they're saying that like these particles, when you get down to a level of nature where things are very, very teeny, super teeny, amazingly teeny, some things happen without causes. Okay. And here's some of the examples. I'm going to go in order this. I could explain it now, but all right, for example, they cite as evidence of this uncaused phenomenon. One of the instances they cite is that we're not able to predict the rate of decay of a single radioactive isotopes. In other words, radioactive isotopes decay, they kind of like transform into other substances, whatever, and so we can't predict exactly when a single radioactive isotope is going to decay. We just, we don't have that information, and we'll go into why we don't later. But some scientists say, well, if we can't predict the rate of decay of radioactive isotopes, that means that phenomenon is uncaused. And that conclusion is completely unscientific. In other words, like it's based on ignorance. It's based on, well, we can't see something is happening, so we're going to say that it can't be caused. An absurd conclusion, again. And again, this is based on the scientists' need, psychological need, emotional need to believe that we're in control of our fates. Because like some people, this is scary. Some people to acknowledge that absolutely nothing is up to us would sap them of meaning. Their lives would become meaningless. Like I've dealt with this idea for decades, and like believe me, you get over it. You get over it because we don't have a free will. In other words, like the reason you get over it is like we're hardwired to seek pleasure and avoid pain. We have to do that. So like, you think about the fact, for example, like think about the fact we're all going to die eventually. We don't live forever. We get accustomed to that. We enjoy reality. All right, so in that same way, we would get accustomed, the people who have, difficulty accepting that absolutely nothing is up to us would get accustomed to that fact. And what is the meaning of our lives? Well, basically it's about happiness. We're designed to seek pleasure, avoid pain, to become as happy as possible. That's what our purpose is. We have no idea what the purpose of the universe is. We don't know why the universe exists. I'm not sure we'll ever know that, but we kind of know our purpose as human beings. All right, so they bring up these other instances, like for example, and the main thing is like they refer to what's known as the Heisenberg uncertainty principle that I went through before, but I'll go through it again because it's relevant here. Basically, the Heisenberg uncertainty principle stipulates, and it's accurate, it's not been challenged successfully, it's the way things work. You can't simultaneously measure the position and momentum of a particle. The idea behind that is pretty clear to see. Like in the macro world, let's say you've got a tiny little photon, right? And let's say this is a baseball. Let's say it's a book, whatever, flying through space. Okay, you're trying to measure its position and momentum at the same time with this photon or a series of photons, whatever, a beam of light, whatever. And you could do that simultaneously because like the photon is so small relative to the book that it doesn't change its momentum. If the book is going up like that and the photon hits against it, it's not going to make it veer off and all, right? But at the quantum level, you've got teeny little particles that are kind of like about the same size relative to each other. There's vast differences between them, but like, for our purpose, they're within the same ballpark. So you have it kind of like a photon here and an electron here. You're trying to measure its simultaneous position and momentum. If you try to, you'll get its position right? Because you'll impact it and the light will bounce back, whatever, and you'll be able to find where that electron is. But the impact of the little photon going into the electron will change the momentum. It'll make it veer off into a different direction with a different velocity. Remember, momentum is direction and velocity of a particle, of mass energy. All right, so fine. Nobody disputes that. But some scientists, again, for no logical reason, because the logic behind it is just not there, they conclude that since we can't simultaneously measure the position and momentum of anything, a particle, then they say that particle doesn't, first they say that particle doesn't have a simultaneous position and momentum, which is completely absurd, but then they say that the behavior of that particle, because we can't measure its position and momentum simultaneously, is uncaused. An absurd conclusion. It has no basis in logic and reasoning. It's completely absurd. So the idea is, all right, so I'll read from the book. While the causal mechanisms of the above phenomenon, radioactive decay and particle movement, are and may forever remain unknown, this ignorance does not justify a conclusion that they are uncaused. In other words, they're justifying their conclusion based on ignorance. And in science, you don't do that. You say you don't know, but you can't, say, well, because I don't see something happening, it can't be happening. Or because more strongly, actually, because I don't see something being caused, it's not being caused. Because again, in the last section, starting on page 7, we explained how causality is so fundamental to nature, to reality, that nothing could and would happen without it. So attempting to refute it is fatally flawed, and it can't work. All right. So anyway, now I get into what happened. Before quantum mechanics, you didn't have all this quantum Heisenberg uncertainty principle and stuff. You had Newtonian physics, which in Newtonian physics, as I explained before, you could simultaneously measure macro objects like books and grapefruits and baseballs and planets, whatever, with simultaneously. And but all right, so in the micro world, you can't do that. And so what happens is in order to, I'm not sure. Let me see where we're going here. Okay, what happens is, in order to measure phenomenon at the quantum level, because we can't, measure the simultaneous position and momentum, what we do is, of a single particle, what we do is measure the simultaneous position and momentum of groups of particles. And that's how we get quantum measurements. That's, in fact, the technique. So in other words, let's say this book is not like a macro object. Let's say, it's acting as but it's a group of electrons. So we'll fire photons on it repeatedly, 10, 20, 100, 1,000 times. And each time we measure it, we're going to get a slightly different result, because that's because it's not exact. But those measurements, those repeated measurements, are going to form the data set for our then basically formulating probabilities. In other words, based on our shooting photons 1,000 times at this group of electrons, we will be able to determine the probability that one singular electron within this group, is at a certain point at one moment in time, and at a future moment is going to be at a different point. And actually, we can do this very, very precisely. In other words, quantum mechanics is so precise a method that we can measure the distance between, let's say, for example, New York and California within a hair's breadth. If you have these the parameters, the latitude, longitude, all that stuff. But all right, so basically, what I'm trying to say. Then some physicists say, well, because we rely on probabilities to measure quantum events, they make the mistaken conclusion of thinking that particle behavior is probabilistic. And it's completely insane. Again, you got to wonder how these people got through, got their PhDs and all. Because in other words, that's like saying, let's say you flip a coin, right? Okay, the probability of it landing heads is 50%, okay? That's a probability. You're determining the probability based on the fact that the coin has two sides, all right? But just because there is a probability of it landing on heads, 50%, doesn't mean that the coin is, the behavior of the coin as it's like moving through the air and all, is probabilistic. No, reality does not function probabilistically. We use probabilities in order to determine the behavior of certain phenomenon. So, all right, so so in other words, like what I'm trying to say is some people say, well, it's the probabilistic nature of reality that could potentially give us free will, and they never explain how that works because it doesn't work. In other words, even if it was true, even if like in some bizarro universe the reality behaved probabilistically, that wouldn't give us free will either, because our decisions being probabilistic, what's that mean? If we're doing things probabilistically, we're not doing them of our free will, because to do something of our free will means we're doing it and nothing that we're not in control of is making us do it or taking part in the doing of it. And naturally, we wouldn't be in control of the probabilities. I'm running out of time. All right, so I hope you understand this section, and in the next section, we're going to get into we're going to refute some published free will defenses, because there's a little more that I didn't get into on page 10, but I think I basically covered it actually. All right, so thanks for watching, and I will see you next time. And again, so that we're going to be on page 11, and it's chapter 3 called Refutation of Free Will, Published Free Will Defenses, where I go through 4 published articles and refute their claims and all. All right, thanks for watching, and I'll see you again next time.